Welcome to the video lesson. I am Muthulakshmi, Assistant Professor in the Department of Computer Application, SFR College for Women, Sivakasi. In today's class, we are going to see the video lesson on the fundamental data structures stack. In day-to-day life, we are organizing the things in particular order to access the things easily. Like that, the data in computers are organized to access them easily for different purposes. The fundamental data structure is stack. In this lesson, we see how to organize the data using stack, how the data are retrieved using push and pop operation. Let's go into the video lesson. These are the learning objectives. First one, what is stack, then what are the representation of stack. In this video, we see how to represent a stack using array and linked list. The operations in stacks are push, pop and peek, and then we see how to implement them using algorithms, that is the pseudocode. How the stack operations are performed in computer. I am taking a simple example. In Notepad or some Microsoft Word document editor, we are making a document with some data. Here in this example, I am typing some of the words. You are the designer of your destiny and you are the author of your story, like that. Now I am performing undo operations and deleting some of the data. If I am performing then redo operations, the last data is retrieved now. Here we are using the stack data structures to store the data. That is why we perform the undo and redo operation. Like that, there are many applications are performed based on the stack data structures. Now we see what is data structure. Data structure deals with the study of how the data are organized in memory, how efficiently the data can be retrieved and manipulated. Data structures allows the programmers to write efficiently and retrieved, manipulated and organize the memory. Depends upon the data structures, it classified as primitive data structure and non-primitive data structure, but based on the organizer, it is classified into linear data structure and non-linear data structure. The stack come under the linear data structure, that is sequential organizing of data. First, what is data? A stack is an ordered collection of elements like arrays, but it has a special features that deletion and insertion of element can be done at the only one end called top of the stack. So, we can perform only the push and pop operation only at the top. So, we follow the property called LIFO, last in first out. We see some example in Microsoft Word. So, last enter document, last enter data is deleted at the first. This is the basic idea. Stack is an ADT commonly used in programming language. It behaves like a real world stack. Example, a deck of cards, a pile of plates, etc. It is represented using arrays, structure, pointers and linked list. Stack can be either a fixed or dynamic. So, based on the fixed size, we can implement using arrays, or based on dynamic, we can implement using list. These are the operations in stack. We can push the element at the top of the stack, we can pop the top element, we can create the stack, we can check whether the stack is empty, we can check whether the stack is full. So, we can insert only a particular limited number of elements, that is maximum limited elements only in the stack. This is the pseudocode. First one, we have to fix the maximum items. Max number of items might be on the stack. If you are fixing 5 items means we can insert only 5 items in the stack. The data type of the item in the stack, we can include any data type, but it must be in a homogeneous. It may be integer or float, anything, but the structure contain only homogeneous data. The operations are make empty, boolean is empty, boolean is full, boolean, item type, new item, item type and item. These are the functions that we are created for the stack implementation. First one, function adds new item to the top of the stack. For inserting a new item, the stack might be the stack has been initialized and it is not full. If we can push the element, the stack is not full, then only we can insert an item into the stack. So, we have to check whether the stack is full or not before inserting an element. Post condition, the new item is at the top of the stack, we can peek the element. Peek means we can see what element at the top of the stack. Pop means removing the top element from the stack and return the item. Pop contains only the item that is at the top. Precondition is that stack has been initialized and not empty. We cannot perform pop in an empty stack. So, we have to check whether the stack is empty or not. If it is not empty, we can do pop operation. Post condition, the top element has been removed from the stack and the item is copy the removed element. The top element is returned as the pop function. This is the operation. First we create the empty stack, then we push the element 2 at the top of the stack, and the maximum size is 4, it is indexed as 0, 1, 2, 3, and the top element is 2, that is inserted at the 0th index. Then the element 3 is inserted, then element 5 is inserted, then element 6 can be inserted. Here I am inserting 2, 3, 5 in index 1, 2, 3. The top element is 5. Then popping the element 1, then we can pop the last in the first out. So, the top element is out first. This is implemented using array. So, we can implement create an array for the stack. Make an empty, these are the functions, is we have to check whether the stack is empty before pop operation is performed. Before push, we have to check whether the stack is full or not. And this is the implementation. Stack type top equal to -1. This is the initialization process. First we have to initialize the top equal to 1. After pushing the element, the indexing start from 0. Make empty. If you want to make all the stack to be empty, then we have to set the same top equal to -1. Is empty means it check whether the stack is empty or not. The stack is full means the top reaches the maximum item -1, because we start from index 0. So, the maximum item is -1. Then pushing the item means the item at the top, item is the array for inserting the element. So, item top equal to new item of, here we inserting a new item in the stack. Then if you are performing pop operation, item equal to item of top. The item at the top of the element, top of the stack is fetched into the item and it returns the value that is at the top of the stack. Then minus the top to minus. So, if you have here the top index is 4, then -1 equal to 3. Then stack overflow. Overflow means when the condition occur, when the stack is filled, again we push the element into the stack, the condition resulting the stack overflow. Underflow means we are popping the element from an empty stack, we will call this condition as underflow. The stack is implemented using the second method, singly linked list. Singly linked list is a data structure consisting of sequence of nodes. Here we are using the pointers to point out the next element. The operations are insert at the front, remove front, insert back, remove back. First one, inserting at the front. See, the nodes are created as follows: A, B, C, D. The first one is a head and the last one is tail. If you want to insert an item in a front or at the end, we have to create a new node. If you want to insert an item at the front, example, we can insert the item E means make the node and make it as a first element, the head is point to the new element. Here the new element E is inserted at the front, then E is added to the data structure, singly linked list data structure, the head is pointed to E. Next, the head is to 0, then tail to 0. Next, inserting at the front, allot a new node, have a new node point to the old head, update the head point to the new node. This is the steps we have to follow if you are inserting the front. Then inserting the front, if the tail is null, update the tail to point to the head node. Both head and tail point to the new node. Removing at the front, if you want to remove the element from the front, then the head will be point to the next node and then deleting the front one. Here I am deleting the element A, then the head is moved to the element B, then the element A is removed. If this is the last element, the head and tail to be point to the single element, return the element of previous head and delete the node. So, both head and tail point to the single node. Removing from the front, both it contain a list of elements or a single element. If it is a single element, both head and tail point to the single node. Then removing from the front, update the head to point to the next in the list, return the element of previous head and delete the node. So, we remove the front element, then removing at the front, update the head to point to the next node in the list, return the element of previous head and delete the node. If the head is null, update it to tail to null. If there is no element means we have to update the tail to null. Then inserting at the back. How to insert the element at the back means we can create a new node, then if the tail is null, update the head and tail to point to the new node, otherwise have the old tail point to the new node, update the tail to point to the new node. Now the elements in the list are C, D, E. So the new element E is the tail element. New element tail element, then the new element F is make us a tail element. So, update the tail to point to the new node. Removing at the back, no efficient way to do so, because this is the last node, we are eliminating the last node, we can use a singly linked list if the operation is commonly used. We can eliminate the last node and point the tail to focus on the previous node E. And this is the simple visualization of singly linked list. We can implement a stack with a singly linked list. The top element of the stack is the first node of the list. The space used is big O of n, and each operation of the stack ADT takes big O of 1 time. These are the some sample programs. I am creating a new stack and perform a push operation, that is 0 to less than 4. I am pushing the element, find the element, what is the output. So, if you find the output, find the answer. The character version I am showing here. In the what is the error? It is character here. Then this is the summary of stack operation. The complexity of different implementers are listed here. For implementing an array, stack using array, the pop operation takes big O of 1, same in the singly linked list. Push operation takes big O of 1, and then singly linked list also big O of n. Then top of and then size of empty of these operation takes big O of 1. But the implementation complexity varies in arrays and stack. The arrays takes a much easy method for implementing the stack compared to the linked list. So, depends upon our application, we can use either the singly linked list or array for implementing the stack. The operations push, pop, peek, these are the basic operation. It lists for inserting the element, deleting an element, and which element at the top of the stack, that is the peek operations. This will be useful for basic data structure stack. We can see what are the applications of stack in our future videos. Thanks for watching.